Hi, everyone, and welcome to Doris Summit. My name is Naiqing, and I'm the go-to-market specialist from AWS Compute team. Today, I'm really excited to talk about Amazon Compute Service EC2, and we'll be focusing on EC2 instance powered by Graviton and how they can benefit your workloads. Amazon provides broad list and deep list compute platform choice. We have over 850 instance types across different families, from general purpose to specialized workloads. We have multiple processor architecture, diverse instance families, and global availability. We also provide granular sizing options from nano to bare metal servers so that we can match your requirements and for you to choose the best hardware for your specific use case. As mentioned, Amazon EC2 offers you multiple processor architectures, ensure you can optimize for your workload requirements. As you can see on this slide, we offer 4 distinct processor architectures. Among these 4, Graviton is our custom ARM-based processor designed for the cloud. So today we will focus on this so you can understand why they represent such a compelling option for running your workload. Now let's dive into AWS Graviton processors. We have been continuously innovating in this space, and today we have 4 generations of Graviton processor available. Start with Graviton 1, our first generation ARM processor, launched in 2018, proved that custom silicon could deliver real cloud benefits. Graviton 2, released in 2019, delivered up to 40% better performance than the comparable x86 instance, making ARM a serious player for enterprise workloads. Graviton 3, launched in 2021, brought up to 25% better compute performance than Graviton 2. And with enhanced capability for HPC and for machine learning workloads. Graviton 4, our latest generation available now, delivers up to 30% better compute performance and 75 more memory bandwidth than Graviton 3, setting a new standard for cloud compute efficiency. So how this relates to you? The answer comes down to 3 business benefits. AWS Graviton delivers the best price performance available in EC2 today. This isn't just marketing. It's measurable value that directly impacts your business. When you migrate your workloads to Graviton-based instance, you can achieve up to 20% lower cost compared to equivalent x86 instance. This means the same performance for less money or better performance for the same budget. Graviton is significantly more energy efficient, consuming up to 60% less energy than comparable x86 processors. This translates to smaller carbon footprint for your infrastructure and meet your organization's environment goals. It's a win-win proposition that makes both financial and environmental sense. This benefit sounds compelling. Let's look at more depth what we can offer with the processor. Now let's look at the comprehensive family of EC2 instance powered by Graviton. Graviton isn't just available in a few specialized instances. We offer a complete range across all major instance family. General purpose for balanced performance, compute optimized for compute-intensive workloads, and same goes for memory and storage. Also for specific workload on accelerated computing or HPC. Whether you are running small deployment cluster or large production analytics workload, there's a Graviton-powered instance that's optimized for your specific requirements. With this broader selection of instances available, let's examine into the workload. So one common misconception about ARM is that they're only suitable for specific workloads. AWS Graviton breaks that myth with broader workload across diverse use cases, from web service to database or more specialized HPC ML cases. Why this matters? Graviton can handle whatever you throw at it. There is no architectural limitations. And the majority of the ecosystem, it provides extensive software compatibility and optimization. Migration confidence, your existing application will run efficiently. Major enterprises across industry are already running production workloads on Graviton, proving its reliability and performance across diverse use cases. Now let's see how this broader capability translates to our own managed service. The performance and cost benefit of Graviton are so compelling that AWS has extensively adopted across our managed service portfolio. As you can see, database, analytics, containers, serverless, machine learning, they are all leveraging Graviton. This isn't just about offering choice, it's about delivering better value to our customer. This adoption of Graviton across our managed service proves our confidence in this technology. When we use it to power our own service, you can trust it will deliver the same benefit for your workloads. One of the biggest concerns when considering a new processor architecture is adoption complexity. With Graviton, we have made the transition as seamless as possible for managed service and ISV service. Then for the easy workload, most applications run on Graviton with little no modification. Docker containers typically work out of box on Graviton instance too. For more complex ones, we also provide comprehensive resource to ensure smooth adoption, step-by-step documentation, tools for performance testing, and we provide technical support throughout the migration journey. This ease of adoption also led to remarkable customer uptake, which brings us to some impressive adoption numbers. Over the past 2 years, an incredible 50% of all new compute capacity added to AWS has been powered by Graviton processor. This isn't just growth, it's a fundamental shift in how cloud computing is being deployed. This number represents the customer confidence, proof performance, and market leadership and ecosystem maturity. When half of all new cloud compute capacity choose Graviton, it's clear that this isn't just a niche technology. This widespread adoption means you are not taking a risk by choosing Graviton for your workload. You are joining the majority of new cloud deployments that have already recognized its value proposition. So let's dive deeper into our latest generation, Graviton 4. The 4th generation processor delivers significant performance advance, 30% better compute performance compared to Graviton 3, delivering faster processing for your workload. 3x more vCPUs, up to 192 vCPUs in a single instance, enabling massive parallel processing. And 75% more memory bandwidth, critical for memory-intensive workloads. These improvements makes Graviton 4 particularly well-suited for data workload. And with this foundation of Graviton 4 capability, let's examine into more technical details. The hardware behind this capability is impressive. With Graviton 4, we increased the number of cores in every CPU by 50%. We have 96 nanoverse V2 cores. And we look at the real workloads. We saw that their working set just wasn't fitting into the caches we had. So now every of their cores have 2 megabytes L2 cache. That lets you put more of your data and instructions close to the cores and they execute faster. Just like Graviton 3, it's a 7-chiplet design, where we got more cores, more DDR, 12 channels of DDR5 5600. It's the fastest in EC2, and up to 69 links of PCIe Gen 5. These specifications translate directly to the workload performance benefits. When we started Graviton 1, it was about proving you can have another architecture in EC2. We saw some pretty good performance for some workload, and then for Graviton 2, we increased those workloads substantially. People running Java applications, Go applications, database, and tons of other workloads, making ARM viable for mainstream enterprise workloads across all major application categories. Then for Graviton 3, increased performance. We also added support for machine learning, HPC, SIMD operations, bring advanced computing capability to specialized workloads. What else? Our customer wants bigger instance to grow with their business. So with Graviton 4, we have an option to support scale-up workload. Every single socket now has 50% more cores. For the small number of workloads that needs to be scaled up and can't be scaled out, we are supporting the coherent multi-socket. So two Graviton CPUs can connect together and deliver single system that 3x more cores than Graviton 3. This technical advance translates into real-world performance for our customers. When we developed Graviton 4, we paid a lot of attention to real-world workload and looking at how they perform. Understanding how real-world workload run on this system. So to help us visualize this, we use radar graphs, looks like this. This radar chart provides a visual comparison of chip sensitivity across multiple dimensions, how sensitivity different workloads are to CPU performance bottlenecks, with lower sensitivity indicating better and stable performance. If we split a CPU in half, there's a front end which receives instructions, prediction, branch, and which are the left side of this matrix. And there's the back half of the chip, which executes the instructions. Ultimately, this result front end and back end stores. So that we can test the workload, we can look at them to understand how will it perform on the processor and what's it sensitive to. So let's see some examples. This slide demonstrates something critical, how Graviton performs not just in benchmarks, but in real-world applications. As just explained, each radar chart compares front-end and back-end CPU metrics. The gray area on the left shows the front-end CPU sensitivity, how much the workload depends on branch prediction, instruction cache, and pipeline performance. And the blue areas are the backend CPU sensitivity, how much the workload depends on data processing, memory hierarchy, and execution units. First, you can see the first chart. This is a traditional benchmark. You can see it stressing the last level cache, but not a lot else. This makes sense because when people build benchmark, usually they extract some code out of real application and loop through that hot code many times to get stable performance they can measure. By doing that, it's not sensitive to many things. But when we look at real workload, we see a different set of graphs. Here we see Cassandra, Groovy, Nginx. Those are common workloads we can find in the cloud. When we look at them, we can see they bottleneck by different set of things. Cassandra particularly sensitive to front-end CPU metrics, which are critical for database query. And Groovy demonstrates moderate sensitivity across both front-end and back-end, reflecting the dynamic nature of the language. Nginx shows lower sensitivity overall, but with a notable spike on instruction L1 cache. This makes sense because web servers rely heavily on efficient instructions. So the key insight here is different workload, different bottleneck. So how can we solve those problems? You can see on the right the improvements Graviton 4 did. First thing we did is to double the L2 cache size. This means more instructions are now closer to the cores. With the cores we chosen, it's better at predicting branch. It's got large BTB, it can fetch more instruction into the front and execute faster. And Graviton 4 has a number of architectural improvements. It supports SVE2 and it has new control flow integrity instructions like BTI. With all of that, how does it perform? Now let's look at performance improvements that real workload achieve. With MySQL as a prime example, we are seeing 40% MySQL performance improvements and lower sensitivity across multiple dimensions, meaning more stable and more predictable performance. Last but most important, beyond performance and cost benefit, Graviton processor delivers significant sustainability advantage that align with modern corporate environment goals. This combination of performance, cost efficiency, and sustainability makes Graviton 4 the ideal choice for your workload. Okay, let me summarize the key benefit of Graviton-based EC2 instance. First, significant cost saving and environmental benefit, up to 40% better price performance and up to 60% less energy. Second, broader workload support and easy migration adoption. And also Graviton available today in nearly all AWS regions. Thank you for your attention and hope you will start your Graviton journey soon.